小在50到80。应该90。这个就不用学。
Lagi bikin box juga.
Okay, last time I tried to plot 4 companies box plot. Okay, and you need to put your data look like this one. Okay, so we have a different company. Okay, so each company there are 20 observations. Okay, so you need to put them in one column. So this is the dependent variable. Okay, the second company. Okay. There are 20 observations, and this is the customer satisfaction. The third company, okay, there are 20 data. So you need to put them in one column for the dependent variable, and the independent variable in the other column. And you need to define, okay, 1, 2, 3, 4 means different companies. Okay. Then the graphic, okay, this is, you can plot it. So last week, I think a couple of weeks ago, okay, we have 4 companies here, but there are too many we cannot use. But if you put these, so they are companies, so there are 4 different kind of companies. And the dependent variable you just throw to here. Okay. So the first thing is you need to click this one and choose this one. Okay, put here. And then throw the company to the x-axis. And the dependent variable to the y-axis. Okay. And then you can plot it. And since most data is between 60 to 81, so if you want to put a zoom in, okay, so you just click it.
Dimas.
Bingung TV.
Okay, you can choose from 60 to 80, the maximum is 81, so we can put here, and put the major improvement maybe 5, just 5. Okay, and just click this, apply. So you can see the scale is between 60 to 85. Okay, so you can see different companies. So the top part between different companies. Okay, so the idea is in the SPSS you always put your variable in one column. In one column. Okay, this is dependent variable. This is independent variable. They are all different kind of companies. So that's why you can plot it. Okay. Okay. So this is chapter 3 box plot. And tonight I'm going to talk about interval estimation about the population mean. Okay. There are sigma unknown and known. Okay. Usually we use the sample size is bigger than 30 when we use Z distribution. And when sample size is less than 30, we use T distribution. And we can get the confidence interval. But the software always conduct the t-test for you. So you cannot get a z-test. So you need to get it by hand, by formula. And if you design your margin error, how big the sample size you need to collect, okay, you can calculate. And the population proportion, we are interested in the population proportions confidence. Okay. So margin error, okay. And this is the average, sample average. We call point estimate, plus minus margin error. And the margin error equal, okay, this is the population mean. And the sample average, this is plus, this is minus. So within this range, okay, we call confidence interval. And how much confidence you are. So usually we have a 1 minus alpha. Okay, alpha can be 5%, 10%, or 1%. The bigger the alpha, okay, the bigger the alpha. The tighter the confidence interval. Okay. And the z value is how much standard deviation. Okay. So this is the formula for the population mean. Okay, we can get the interval estimate or confidence interval for population mean. So it's equal the sample average plus minus the z is the how much standard deviation. Okay, from the standardized normal distribution. And this is the we call standard error. Okay. Standard error. Okay. So the confidence interval is depend on the value of alpha. Alpha can be 1% or 10%. And okay, some in most cases, okay, they prefer 5%. Okay, so how do you know when alpha is 5%, the z value is equal 1.96? You know how to get it?
Yeah, therefore I just need to.
Okay, great. So there is the standardized normal distribution. Okay. If alpha is 1%, so this is 0.005. So when you look at the table, you should look at 0.995. Okay, so the value will be look at the value should be 2.57.
5.8.
And this is 0.9945. And this z value is the probability is 0.99.
Still there.
I don't have a full table, okay? Forty-nine. 51.
Akong tingin yun, mukhang na.
So we are looking for 0.9995. So it's here. So it will be 2.575 or 6. This is the other table will look like 0.49. So if you look at the table,
2,6 2,61 2,61
the other table will look like this. Okay. There are two kinds of table. Okay. One is from infinity to this point. The other one is from 0 to this point. Okay. And this is probability. We are 99% confident interval. So this means the alpha is 0.001. So this value will be 0.005. So if you add them together, it will be equal 0.01. Okay. So alpha is 1%. Okay, the counting interval is 99%. So you will look at the value of 0.9950, and the z value will be 2.576. Either side, okay, either way, okay. So this is plus, this is minus. Okay, if alpha is 10%, so the common interval will be 90%. So the z value will be 5%. 5%. So in the middle, okay, there will be 90%. So for each side, there are 5%. 5%. So in the middle, okay, we're 95%. So if you look at the table, it will be 1.645. So the larger value of alpha, the smaller the value of the counter interval, and the smaller the standard deviation. Okay. So if you are buyer, you prefer use bigger alpha. If you are seller, you prefer use small alpha. So you have more big counter interval. Seller try to protect themselves, and the buyer they prefer use big alpha, so they want more precise counter interval. Okay. So the meaning of 90% or 95% or 99%. It's just a probability. Okay. It's a probability. It means you are alpha, maybe 5% or 1%, and 10% you are not sure. Maybe sometimes you will make, you do not make the exact estimate. Okay, so we call confidence interval for 30, any kind of probability. Okay. I will give you the data and let you do the calculation. Okay. And this is done by hand. Okay, one retail company, they are interested to open a new outlet in one particular area, and they like to know the confidence interval for the population's annual income. So they collect data from this area. There are 36 households. Their average income is $41,000. The standard deviation is $4,500, and they are looking for 95%. Okay, so for the 95%, that means the z value will be 1.96. That's the standard deviation. How much standard deviation? For one standard deviation equal this one, we call this is the standard error. Standard error. And based on this formula, okay, the population standard deviation or sample standard deviation is 4,500. The sample size is 36. Okay, so you got the standard error. Okay, so and you multiply by 1.96 standard deviation. One standard deviation is this amount. Okay, there are 1.96 standard deviation. The 1.96 standard deviation based on the confidence. Okay, so you got this is we call the margin of error. Margin of error. Okay, so this is margin error plus minus. So the confidence interval will be between 39,000 to 42,000, and the software cannot get this z value for you. Software always get the t value for you. So let me show you the example.
Bukan itu. Open. Data.
This is how much money for customers spend for their meal in the restaurant. And there are 64 samples in Houston, Texas. And the question there are two questions. First one, get 99 confidence interval. What's the margin error? Margin error. Use this one, okay? No more. You have this. It's empty. Okay. You don't have this one. You just have this one. Okay. Just one variable amount. How much money you spend for
Clear,
your meal? Okay.
Clear, klik kanan clear. Kan.
You just choose this one. And here, the question asks us 99%, so you type 99 instead of 95. The default is always 95%. And the value you got here,
Option. 99. Okay.
This is X bar. This is Z. And X bar is normal distribution based on central limit zero. So the mean is mu, the standard deviation. Okay, and the Z is standardized normal distribution. The mean is 0 and the standard deviation is 1. Okay, so 95% and 99%. So we already know 99%. We won't get the 99%. Oh. That means here is 0.005. We already know the Z value 0 is equal to 2.576. This is negative 2.576. Okay, this is positive, this is negative. Okay, either side is 0.5% because we are 99% confidence. And the sample, the question asks us the margin error. Margin error will be equal Z multiplied by this one. And the Z in this case is 2. The standard deviation, the question maybe give you or not. The question is 6. And the sample here is 64. And the sample standard deviation here is 6.88. It's not equal this one. Okay? But based on the problem, the data provided to you, okay, you just put 6 here. But here is 6.889. Okay, standard error of mean. This is not the same. Okay. The real data, the sample standard deviation is 6.89, okay, instead of 6. And the n is equal 64. So you got the standard error of mean. If you do it by hand, based on the formula, you will get a different answer, okay? You don't do this one, okay? This is from the output, and this is for t-test. So the common interval is not the same as if you apply the mu equals sample average plus minus this number, you won't get the same answer as this one. This is only for t-test, t-distribution. So they are two different. The software always give you the t come from t-test, not the z. Okay. If you want to get z, do it by yourself. Okay, based on the formula. Okay, look at the table. Okay, you will get two different answers. Okay. No matter how big the sample size you are, the output from the software always give you the t, not the z. Okay. You won't get the z unless you do it by yourself. Okay. So you won't get the z, okay. Do it by yourself, okay. The sample standard deviation is not the same as the sample standard deviation. The population standard deviation, the problem give you is 6, not the 6.89. So it's different. There are two different formulas, okay. So this is the second case, the second phenomenon. Okay, this is they use a t-test. Okay, so when the sample size is less than 30, the population standard deviation is unknown. You use t. T look like z. Okay, yeah, the mean is the same. Okay, 0, but t. The variability of T distribution is much bigger than Z. Okay, depend on the degree of freedom. The degree of freedom equal to n minus 1. Okay, the bigger the sample size, the bigger the degree of freedom, the smaller the standard deviation. So you can look at a table like this one. This is T table, okay. Okay, if alpha is 5%, so for each side it's 0.025. And for standard normal distribution, this is the correct answer. But for T distribution, it's less than infinity. So the table, if you got the standard deviation from T table, it's always bigger than this law. This law is from standardized normal distribution for Z. Okay, this is for T. Okay, so the smaller the sample size, the smaller degree of freedom, you can see the bigger the standard deviation. Okay. The formula is different. Okay, this is T. Here is Z. Okay, there are two different distributions. Everything almost the same except the table. And this table will be the smaller the sample size, the bigger the standard deviation. Okay, the wider the confidence interval. Okay. And this is sample standard deviation. Here, if you are given the population standard deviation, you just put the population standard deviation. But here is sample standard deviation, different. Okay. There is a problem here, and you are interested in what's the average rent near the campus 1 kilometer, within 1 kilometer. And they check 16 departments and apartment. And the average rent is $750,000. And the sample standard deviation is $55. So they are looking for 95%. 95%. For Z distribution, 95% the Z value will be 1.96. But for T, it's much wider than 1.96. It's 2.13. Okay, the degree of freedom is 15 because the sample size is 16. So the degree of freedom is n minus 1, so it's 15. So if you look at the 95%, just look at the 2.5%. Okay, for either side. Okay, so the area in upper tail is 2.5%. Okay. %. So alpha is 5%. So on either side, %2.5%. And this is not Z anymore. The T. And the T for Z is 1.96. The Z value, the standard deviation from 0, from the mean to the 2.5% for the upper tail. The standard deviation for Z is 1.96, but for T, the degree of freedom is 15. So the standard deviation is 2. You can see it's different, and this is much wider. Okay. So if you look at the table, okay, from the T table, it's not a 1.96, but it's 2.131 standard deviation. And the sample standard deviation, we call this is the standard error of mean. Okay. This one we call sample average. Okay, sample average, just like the computer output is giving you the standard error of mean, standard error, the X bar, standard deviation. Okay, this one. Okay, And you got the margin error to $29, $29.30. So you can account interval from 720 to 779. Let me get the other problem. Hong Kong.
Chapter 8 Hong Kong. Dari
So the mean, there are 42 samples. Okay, the mean in Hong Kong. Okay, so they ask you what's the 95%? With 95%, what is margin error? Okay, in this case, the default is 95%. Okay, it's there. Okay, so since this is small sample, and this the population standard deviation is known, so you don't need to calculate by hand by the formula. Everything's there. Okay, everything is here. Okay. The sample average $32.66. The standard deviation is 6.82. Okay. The standard error margin, like this one. This one. You got 1.05. This is 682 divided by 42. Take the square root, you will get this one. And the count interval here, okay, is this formula. And you don't need you look at the table. You can get the answer from the output. This is T. So you got your count interval for the whole things. Okay, for the lower bound, and upper bound. You got it.